One. A very good evening to all. So how are you? How is everyone? So welcome to our next session of our atomic series, which is on design of concrete structure. So this I am going to be taking in two parts. In the today's session, we are going to be discussing design of concrete structures. In the next session, we are going to be discussing pre-stressed concrete questions, right? So today we are only going to be discussing about design of concrete structures. Is it clear? So first of all, quickly tell me, all those who have joined already, good evening everyone. Welcome guys. A very good evening to all. So join fast, quick everyone. Join fast, quick everyone guys. Hello everyone. So guys, welcome to our BYJU'S Exam Prep English platform. So do subscribe to the channel everyone. Click on the subscribe button. Click on the like button if you like the session, and also click on the bell icon if you want to get notifications, right? And starting with the today's session, okay. So first of all, I will introduce myself. So my name is Rohan Goyal and I have a master's degree in structural engineering from IIC Bangalore. I have also scored an All India rank of 96 in GATE 2020, and these are my area of expertise. Okay, so quickly join everyone. So I'm finding that quickly join everyone. Quickly comment in the chat section and let me know all those who have joined already. Quickly comment in the chat section and let me know all those who have joined already. Join quick everyone, quick. We are about to start. So very interesting session is about to come. Okay, so we are going to be discussing a lot of questions on design of concrete structures, and it is going to be a really fun session, and really you are going to learn a lot. Okay, and so first of all, quickly comment in the chat section everyone. Good evening everyone. Good evening guys. So the PDF of this session is also going to be provided to you. You have to join my Telegram channel, Civil by Rohan Goyal. So you have to join my Telegram channel, Civil by Rohan Goyal. If you search, you will get my Telegram channel, and you can join my Telegram channel by searching Civil by Rohan Goyal. You are going to be provided the PDF of this particular PPT over there after the class itself. So starting with the first question everyone, quickly join everyone. So let us start with the today's session, and here is the first question. Which of the following statement is correct? Which of the following statements is correct? Vanakkam. Subramanian. Vanakkam. So welcome guys. Welcome. So here is the first question. Tell me what is the answer to this particular question. Very easy question, conceptual, and tell me what is the value of this particular answer question. Tell me. Answer in the comment section everyone. I want each and every one of to answer in the comment section. Which one of the following statement is correct? The characteristic strength of concrete is higher than the average cube strength, lower than the average cube strength, same as the average cube strength, and higher than 90% of the average cube strength. A, B, C, D. Tell me what is the answer. Tell me what is the answer. Characteristic strength of concrete. Characteristic strength of concrete. Tell me what is the value. Yes, B, very good. Lower than the average cube strength. So the characteristic strength of concrete corresponds to a value below which So characteristic strength of the concrete corresponds to a value below which not more than 5% of the test results are expected to fail. So only this area is only 5%. And the average strength is also referred to as the mean strength. Mean strength. So from here it is clear that FCK is less than that of the mean strength. So the answer to this sorry, I have clicked the wrong option. I am sorry. I have ticked the wrong option. So it is clear that it is lower than the average cube strength. Characteristic strength of concrete is lower than the average cube strength. If there is any doubt, you can comment in the chat section at any time. I will refer to your doubt. Okay. Moving on to the next question. The minimum grade of reinforced concrete in seawater as per IS 456-2000. Each and every one of you must be able to answer this question. Tell me what is the answer. A, B, C, D. What is the minimum grade of concrete in seawater? For construction in seawater. Or you may also find it in a coastal environment. In a coastal environment, you may also find it like this also. Yes, tell me what is the answer. Very easy. Okay, for minimum grade of concrete for RCC, normal RCC, mild, severe, mild condition. Okay, the minimum grade of concrete is M20. And if it is in coastal environment, it is M30. It is M30. So the answer is yes, very good, very good. Suraj, yes, the answer is M30. Very good. So I am finding that there is only one student who is interested in the BARC and HAL examination. What about others? What about others? Have you lost the hope? Have you guys lost the hope? Tell me. What happened? Have you guys lost the hope? Yes, so Jigadishan has also answered me. Very good. What about others, everyone? Have you lost the hope of clearing the BARC and HAL examination? No, right? No, you still have the hope, right? You can still do it. You just have to keep consistent. You just have to be consistent. Keep on working hard until and unless you reach your goal. So, moving on. The long-term elastic modulus of concrete when age of concrete in loading 28 days is. So what is the long-term modulus of elasticity of concrete? Age of loading of the concrete is 28 days. Tell me. You are also given that the creep coefficient is given to you as 1.6. Creep coefficient is also given to you 1.6. Yes, M30 corresponds to the severe category. Very good. Very good, Sumit. Excellent. Severe category corresponds to when the concrete starts to get exposed to the coastal environment. Okay. Yes, what is the answer? What is the answer? Long-term modulus of elasticity. Okay. Clear? Yes, everyone. What is the answer? Tell me. Yes. So the creep coefficient is already given to you as 1.6. Substitute all the values. So if you simplify this, if you solve this, you will get the answer as A. Right? So the answer is 1800, 8600 megapascal. Each and every one of you getting the same answer, yes or no? Very good. Very good, Sumit. Very good, Jagadish, Suraj. Very good. Moving on to the next question. Moving on to the next question. 1 second. Read the question and tell me the answer. What is the answer? This is the tricky question, and a lot of students tend to give me the wrong answer to this given question. But I have explained the answer to this given question again and again, and still students tend to do the mistake. So, yes, meanwhile you can give me the answer. I will draw the diagram. Okay. So this is the stress strain curve. This is the stress strain curve. Okay. What is the answer? See, this is not the answer, right? Tangent modulus is not the answer. Secant modulus is the answer. Very good, Sumit. Very good. Secant modulus is the answer. So when we define the modulus of velocity of concrete, the modulus of velocity of concrete is defined at a stress level of sigma CBC. Sigma CBC, which is almost equal to FCK by 3. At this particular stress level, the slope is determined at this particular stress level. So this slope over here is your modulus of velocity of concrete, which is 5000 under root FCK. So at this particular stress level, the secant modulus is calculated. Coincidentally, in the actual curve, the value is similar to the tangent modulus. Okay, there is no difference in between tangent and the secant modulus as per the value, but as per the concept, how it is obtained, it is secant modulus. Do you understand the difference? Yes or no? Comment in the chat section and let me know, everyone. Do you understand the difference, everyone? Comment in the chat section and let me know. Yes or no, guys? Yes or no, everyone? Do you understand the difference? A lot of students will give me the answer as tangent modulus, but no, this is tangent modulus is not the answer. Secant modulus is the answer. All right, next question. Stress strain curve of concrete is, so I have already given you the answer. So quickly tell me what is the answer. Now I want answers from each and every one of you. Quickly tell me what is the answer. You already know the stress strain curve, right? You already know the stress strain curve. Now tell me the answer. Yes, everyone. So the stress strain curve of concrete is yes, answer, guys. What is the answer? No, Suraj. You are wrong. What happened? What happened, guys? This is surprising that I am getting a wrong answer to this question. Yes, Babu, exactly, you are right. Suraj, now you have given me the right answer. Jagdish, still you are giving me the wrong answer. Sunil and Jagadish, right? So guys, I have already drawn the stress strain curve. So the stress strain curve of concrete is nearly parabolic. Up to a strain value of 0.002 and it fails at a strain value of 0.0035. Okay, so it is parabolic up to a strain value of 0.002 and a straight line at a strain up to the failure value. So the answer is C. C is the right answer. Is it clear to all? Next question. The stresses in concrete in a reinforced concrete element under sustained load due to creep. So what happens to the stresses due to creep? It is asking what happens to the stresses due to creep. Tell me. Tell me, guys. What happens to the stresses due to creep? Whether they increase with time, decrease with time, remains unchanged or fluctuate. Tell me. What happens? Yes, guys. So due to creep, plastic readjustment of elements take place. Okay, the molecules of concrete will undergo plastic readjustment, due to which the stresses which were induced in the material due to the applied load will get reduced, because the stresses get converted into plastic strain, which is also referred to as creep. Okay, the stresses get converted into plastic strain, which is also referred to as creep. So the stresses reduces with the time. Okay, the stresses get reduced with the time. Next question. Combination of partial safety factor of loads under the limit state of collapse and limit state of serviceability are given. So you have to tell me which of the following is correct. Look carefully, tell me the answer. Look carefully, tell me the answer. You take 2 minutes. You take 2 minutes, tell me the answer. Yes. Tell me the answer, guys. Increase होगा creep coefficient reduces ना sir. Stresses increases होगा creep coefficient reduces. अच्छा, तो देखो creep coefficient किस चीज पे डिपेंड करता है? फर्स्ट ऑफ ऑल, है ना, creep coefficient डिपेंड करता है कि आप कंक्रीट को कितने टाइम बाद लोड कर रहे हो. Creep coefficient depends upon after how much time you are loading the concrete. Okay, and creep tells you what will be the reduction in the stress. Okay, see that creep coefficients help you to determine what will be the strain corresponding to a constant load. Okay, the strain is increasing, stress is not increasing, strain is increasing. You need to understand this point. Okay, the strain is increasing, stress is not increasing. How can stress increase? Okay, so this, when the load is applied, so it will slowly undergo deformation. Okay, delta x, this is elastic deformation, then it will go undergo some plastic deformation, delta y, okay, which we refer to as creep. Okay, there is a very minute change. Okay, the reduction is little, but okay, so but there is some stress reduction. Stress will be how much? If you take any cross section xx, the stress at this cross section will be equal to P by A. Stress will not change. Okay, there is a minute reduction due to creep, but we can say predominantly it is P by A only. Okay, so over here let us see what is the answer. Okay, so lot of students have given me the C as the answer and some of you have given me A as the answer. Let us see. For limit state of collapse, 1.5 dead load plus live load, right? 1.5 dead load plus wind load, that is also right. 1.2 dead load plus live load plus wind load, that is also right. And for limit state of serviceability, dead load plus 0.8 live load plus wind load, that is also true. All the load combinations are right. Let us see the next option also. 1.5 dead load plus live load plus dead load plus, okay, these two are also there, but this is incomplete. Better option is A. Better option is A. C option, 1.5 dead load plus live load, 1.5 dead load plus wind load, or 1.2 dead load plus live load plus wind load. Okay, so collapse is covered, collapse is complete. 1.0 dead load plus live load, 1.0 dead load plus wind load, 1 dead load plus 0.8 live load plus wind load. So this is complete. Serviceability is also complete. So the answer is C. You will find if you see D, over here the collapse is incomplete. Serviceability is complete, but the collapse, there is only one load combination. So the right answer is C. C is the right answer. See, combinations are all are there. Okay, these all are corresponding to collapse and serviceability only. But there are some missing load combinations in the other options. This one is having all the load combinations. Okay. Now you will ask me, sir, earthquake is not there. So the question is, it is assumed that the earthquake load is not acting, only wind load is acting. So that is why it is not taking into consideration the earthquake load. Okay. Next question. Unaffected maximum bending moment at a section of a reinforced concrete beam resulting from a frame analysis are 50, 80, 120 and 180 under dead, live, wind and earthquake loads respectively. So movements are given to you. Bending moments are given to you. Okay. So MD, let us call this MD, ML, live load, dead load, live load, wind load and earthquake load. Okay, these are given. So what is the design movement as per IS 456-2000 as per the limit state of collapse? So what is the design movement? What is the design movement? So first of all, when you are given both, first of all, what are the load combinations? You can also solve. You can take 1 minute to solve, guys. You start solving, everyone. I want you to solve first and tell me what is the answer. We have already seen all the load combinations. You just have to apply all the load combinations and you have to find out what is the maximum bending moment that can be achieved using those load combinations, and that is going to be your design moment, right? The design moment is going to be the maximum of all the load combinations. Tell me the answer. Tell me the answer, everyone. So any answers, everyone? Okay, so I have already got an answer. Very good. So let us find out the answer, right? So what are the three load combinations? Let us see. So first load combination is 1.5 dead load plus live load. Right? So as per this, 1.5 dead load is 50 plus live load is 80. So this will be 130 plus 65. 130 plus 65 is how much? 195. Okay, so 195 is here. We have one option. Next load combination is 1.5 dead load plus wind load or earthquake load, whichever is maximum. So which of the two is maximum, wind load or earthquake load? Earthquake load is maximum. Earthquake load is maximum, so I will consider earthquake load only, which will be equal to 1.5 times dead load plus earthquake load. So 180 plus 50 is 230, and 230 plus 115 is how much? 230 plus 115, 345 kilonewton meter. So we also have one more option, right? Next is 1.2 dead load plus live load plus maximum of wind load and earthquake load, which is equal to 1.2 times 50 plus 80 plus 180, right? So 180 plus 50 is 230, 230 plus 80 is 310, and 310 plus 62, 310 plus 62, 372 kilonewton meter. So the answer is D. D is the right answer. So you have obtained the right answer as 372 kilonewton meter, right? So the answer is D. Very good. So you have to take the maximum of the three. Maximum, whichever is maximum. All right. Next question. At what stress does the first flexural crack appears in an RCC beam made of M25 grade concrete? So tell me, at what stress level first flexural crack is going to appear in an RCC beam subjected to bending, right? Flexural crack means it is subjected to bending. At what stress level? Yes, everyone. So the first flexural crack is going to appear at a stress level of, very good, very good, when the stress reaches modulus of rupture FCR, which is equal to 0.7 under root FCK megapascal, which is equal to 0.7 under root of 25, that is 3.5 megapascal. So the answer is B. B is the right answer. B is the right answer. Next, last question. So a good question, guys, a good question. So I want each and every one of you to be attentive for this particular question. So you are given a beam whose width is 230 mm. Okay. Effective depth is given to you as 400 mm. And it is subjected to a maximum shear force of, factored shear force of 120 kilonewton. The grade of concrete of main steel and stirrups are given to you. Grade of concrete is M20, main steel is Fe415 and stirrup is Fe250. Okay. So concrete, main steel and stirrup. For an area of main steel provided, the design shear strength tau C is given to you as, this is IS 456, sorry, as 0.48 megapascal. The beam is designed for collapse limit state. The spacing of 8 mm two-legged stirrup to be provided. So what is the spacing it is asked? What is the spacing it is asked? So let us write down first of all the given data. B is given to you as 230. So you meanwhile you can solve. I am writing the data. Meanwhile you can start solving. All right. So first of all, for what value of the shear force will you design? For what value of the shear force will you design your shear reinforcement? So this much amount of the shear stress can be resisted by concrete, whereby can be resisted by the RCC section without any shear reinforcement. So what is the shear force that can be resisted by RCC section without any shear reinforcement? It will be tau C into BD. Now this is a Newton converted into kilonewton. So if you simplify me this, can you tell me what is this value? Can you tell me what is this value? So 44.16. Okay. Now you have to design your shear reinforcement for a shear force of Vu minus Vc, which is equal to 120 minus 144.16. So this is the value of the shear force that you have to design your shear reinforcement for. That is this value. If there is any doubt, you can ask me at any point, okay? If you have got the answer, you can comment in the chat section. I guess you guys are giving me the answer as B. B, let us check, okay? Let us check what is the right answer. So this is the value of the shear force for which we have to design the spacing of the shear reinforcement. So what is the formula? Vs is equal to d upon Sv, ASV into 0.87 Fy. That is stress into area. Okay, number of stirrups into area into stress. So Sv will be equal to d ASV 0.87 Fy divided by Vs, which is equal to d is 400. ASV is how much? Two-legged, how much? 8 mm dia. Two-legged 8 mm dia, right? And the grade of stirrup is Fe 250. So Fy will be 250 divided by Vs, that is 75.84 into 10 to the power of 3. So this you will get in mm. So tell me what is the value you are getting. Tell me what is the value you are getting, guys. Tell me what is the value you are getting, guys. One 115.32 mm. So this is the spacing of the stirrup that we are getting. We have now, lastly, we will also check what is the minimum requirement, right? SV minimum requirement. So ASV upon B into SV should be greater than equal to 0.4 divided by 0.87 Fy, right? So you have to check the minimum requirement also. So SV should be less than or equal to 0.87 into 250 into two-legged 8 mm dia, 0.4 into B, that is 230. So from here your SV should be less than equal to how much? Tell me what is the value you are getting. Calculate. You can calculate quickly. Quickly calculate, everyone. If you get the answer, you can comment in the chat section. How much you are getting? This is 250, sorry. This is 250, right? So 237, I guess you are getting right. 237.6 mm. So obviously it is less than this, so it is satisfied. The minimum, see, you are not paying attention, Jagadish. So it was, I have accidentally written 225, it was 250, right? So you are not paying attention, neither are you paying the attention, so you have to see this yourself, right? Sometimes we may do a mistake on the screen, but you guys are students, you should not do the mistakes, right? Alright, so the answer to this given question will be 115, right? So with this, we wind up our session, and I hope you like the session. So if you like the session, click on the like button, do share the session and subscribe to our channel, okay? And the PDF is also going to be provided after the session, okay, on my Telegram channel. You have to join my Telegram channel, Civil by Rohan Goyal. So you have to join the Telegram channel over here, right? So you can join the Telegram channel, and I will upload the PDF after the class. Okay, so that's all. Thank you everyone. Goodbye, take care. And we will meet in the next session, and keep on working hard, guys. Okay.